All right, we are graphing quadratics. Yesterday we graphed quadratics with no linear term. Today we're going to deal with the ones that do have a linear term. So let's go to work. Just as a quick reminder from yesterday, we were talking about quadratics that are in standard form. Standard form is when we get our terms lined up from high to low. And yesterday we identified all the parts of the standard form. And we started back here at the end and looked at the constant. Okay, looked at the constant, which is C. Then we jumped up to the degree and remembered that the degree names the function and all the different things that we realize about functions that we learned previously. Since this is to the second degree, it's therefore called a quadratic. Okay, even though a lot of times we think that's weird, why would quadratic, quad, meaning 4, why would that be a 2? Well, because something to the second power has a nickname of being squared. And a square has 4 sides, is a quadrilateral. And because of that nickname, somebody decided to call these quadratics. Okay, so we're remembering that so that we can remember the name. We're only going to be dealing with quadratics as far as at this moment is what we're graphing. Okay, so since it's a quadratic, we know it's going to be a U-shaped graph. Okay, it's going to be a U-shaped graph. And then our leading coefficient will tell us several things. First, and most importantly, if it's positive, it'll tell us that it'll open up. If it's negative, it'll tell us that it'll open down. And then if the number is greater than 1, it'll get tall and skinny. If the number is a fraction, it'll flatten out and get a little bit fatter. Okay, and those were the main components we looked at yesterday. This in the middle that's surrounded in purple is our linear term. Why is it the linear term? Because it's to the first degree. I affectionately call it the junk in the trunk because it really makes it difficult, okay? Makes it difficult to graph it. And that's what we're going to learn today, okay? We went a little bit further and made sure that we understand that one of the most important parts of the quadratic is the vertex. And the vertex of the parabola is either the highest or lowest point of the parabola. It can also be considered the point where the graph changes directions, okay? And that's what we wanted to start finding. It's one of the 3 main points that make graphing a quadratic possible or easier, okay? And yesterday we focused on the fact that if there's no junk or linear term, the vertex was actually on the y-axis. Well, today we're going to deal with ones that do have a linear term or do have junk, okay? And I want to start this off by remembering the quadratic formula. So if you guys could help me remember the quadratic formula, I would appreciate it. Here we go. Negative b plus or minus square root b squared minus 4ac all over 2a. Now, I bring this up and make you memorize this or remember this because there's part of this quadratic formula we're going to need in order to graph a quadratic that has a linear term. So, here it is. It's this very beginning part of the quadratic formula, okay? When there's a quadratic, when there's a linear term or the junk, we must use this formula. X equals negative b over 2a. And now I've also shown you a place where you could find part of that or find that formula. It's kind of hidden right there in the quadratic formula for you, okay? Now, we use that formula, negative b over 2a, to find the x value of the vertex. And that's it. It only helps us find the x value of the vertex. Okay? So, I'm going to make up a quadratic, okay, for us to look at. Let's say I have f of x equals x squared plus 2x minus 1. Okay? Nice, simple quadratic. And we say, hey, I'd like to graph that so I can show all the possible answers of this quadratic. Well, I would have to then notice that there is, in fact, junk or a linear term. And because there's junk or a linear term, I'm going to have to use this formula. So here we go. X equals. Now, negative b can sometimes be considered opposite of b. You know, if that makes it easier for you to think of. For right now, what is my b term? What are you talking about, Coach Herman? Well, remember, standard form is ax squared plus bx plus c. So what is my b? It's a 2. And I need to use the negative of that or the opposite of that. So in this case, that would be a negative 2. And I put that over 2 times a. Well, what is a in this case? Well, my a is a 1. It's the number in front of the x squared value. So 2 times 1. Understand how I filled that formula in? A lot of nods of the head. That's good. So now negative 2 times 1 is 2. Negative 2 divided by 2 is a negative 1. So far, so good. Now, all that did was tell me the x value of my vertex, which in this case is negative 1. What is my y value? I have no idea. I don't know. Is there some way or something we've done at some point this year that if I have an x value, I can find my y? Glade. Plug it in, right? If we plug in an x value, that gives us our y, doesn't it? Absolutely. So let's do that now. Let's find f of negative 1. Remember, what I find, I'm plugging it in. I'm just going to put that value in for every x, correct? So I'm now going to have negative 1 squared plus 2 times negative 1 minus 1. Just a reminder, we've always, when we plug stuff in, put parentheses around it, right? So we're still doing that. So now let's simplify a little bit. Negative 1 squared is 1. 2 times a negative 1 is a negative 2. And then minus 1. So 1 minus 2 is a negative 1. Negative 1 minus 1 is a negative 2. So f of negative 1 equals negative 2. So what is my y value when x is negative 1? It's negative 2. And now this is my vertex. I have to do all of that work just to find my vertex anytime there's a linear term. Can you handle that? Yeah, I can tell. I don't like it, but you can handle it. Let's try it. Okay? We'll go slow to start, but we'll get there. All right, let's do this first one. All right. F of x equals x squared plus 2x minus 5. All right. Obviously, there's junk in the trunk or there's a linear term. Quickly, what is the formula I've got to use if there's junk in the trunk? X equals negative b over 2a. Good? All right, so in this case, this is my b, this is my a, of course that's my c, right? So this would be the opposite of b, or a negative 2 over 2 times 1, because 1 is my a, and that's a negative 2 over 2, or a negative 1. Everybody good with how I found that? So I have a negative 1 something for my vertex. Matter of fact, I could go ahead right now and draw my axis of symmetry. What is the axis of symmetry? Well, it's that vertical line that goes through the vertex, right? I mean, I don't know exactly where the vertex is, but I know my x value is negative 1, so it's going to be somewhere on that axis of symmetry, isn't it? You see that? Okay, so how do I find out now? Well, I plug it in. So I have to find f of negative 1. I just plug that in for x. So negative 1 squared plus 2 times negative 1 minus 5. Okay. Negative 1 squared is 1. 2 times negative 1 is a negative 2 minus 5. So 1 minus 2 is a negative 1 minus 5 is a negative 6. So there it is. Negative 6. What is my vertex then? Negative 1, negative 6. 1, 2, 3, 4, 5, 6. There is my vertex. Let me go to a different color. That's okay. There's 6. Negative 6. Negative 1. Okay. Well, now what? Now what do I do? Well, same thing that we did yesterday. Yesterday, we found our y-intercept, and because there was no junk, that actually happened to be our vertex, right? And then what would we do? We would look at the leading coefficient and find the point on either side, yes? So let's do that now. Can I now use my leading coefficient? Absolutely. What's my leading coefficient? It's a 1. So from that vertex, I can go up 1, over 1, up 1, over 1. And there is my parabola. Pretty simple. I want to point out one more thing. One more thing. What do I know about my constant? It's still my y-intercept, isn't it? So this graph should cross the y-axis at negative 5. Let's look. 1, 2, 3, 4. Oh, look. At point, I found another way. It's there, isn't it? Cool. I mean, that just verifies what I've already told you, yes? Yes, ma'am.
So if you wanted to, you could just graph that one first and have an idea.
Could have. Absolutely, I could have. Okay. All right, let's go to number 2. Now, on number 2, we're going to do all that same work, okay? But I'm also going to show you what you're supposed to do. I've showed you a few shortcuts from the start, a few simple ways. On this one, I'm going to take a little bit more time, and I'm going to show you what you're supposed to do, okay, just so you have an idea. All right. There is junk, or a linear term, correct? Therefore, I've got to use, let me go back to red, x equals negative b over 2a, right? So in this case, negative b would be a positive 4. Why? Because that's a negative 4 right there. And negative b is the same thing as saying the opposite of b. And what's the opposite of a negative 4? A positive 4, right? Okay. Over 2 times a. And in this case, a is 2. Okay, so 4 over 4, which is 1. All right. So the x value of my vertex is 1. My axis of symmetry is right there at 1. Cool. Now what? Glade. Plug it in. Plug it in. I've now got to find f of 1. I'm plugging that in for the x. Okay. So 2 times 1 squared minus 4 times 1 plus 3. Okay, well, 1 squared is 1. 2 times 1 is 2. Negative 4 times 1 is a negative 4 plus 3. 2 minus 4 is negative 2 plus 3 is a positive 1. So f of 1 is 1. Cool? What is my vertex? 1, 1. Plot that point. Now, I've showed you about the constant. I've showed you about the leading coefficient. Okay? And I'll come back and do those in a minute. But what I want to do right now is I want to show you what you're supposed to do. Mathematically speaking, what you're supposed to do now is, now that you found your vertex, and I have x value of my vertex is 1, I'm supposed to pick 2 points, to the left or to the right. I'm going to go to the right just for argument's sake. So I got to choose 2 and 3. Are you with me? And I'm supposed to do a T-chart. And I'm supposed to take 2 and 3, and I'm supposed to plug them into this equation. So I'm supposed to find f of 2, which would be 2 times 2 squared minus 4 times 2 plus 3. Well, 2 squared is 4. 2 times 4 is 8. Minus 8 plus 3 is 3. You okay with what I did there? I know I did it fast. Okay, now I'm supposed to do it again for 3. We did all this back at the beginning of the year, right? So plug it in. 2 times 3 squared, minus 4 times 3 plus 3. Well, 3 squared is 9. 2 times 9 is 18. Negative 4 times 3 is a negative 12 plus 3. 18 minus 12 is 6. 6 plus 3 is 9. And I'm supposed to plot those 2 points. 2, 3. 2, 3. 1, 2. 1, 2, 3. And 3, 9. 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm supposed to mirror them across that axis of symmetry. So this one mirrored across should be right there, right? It's 1, 2, 1, 2. It's 2 away. And this one here is 1 away, so it should be right there. Yes? And there is my parabola. That's what I'm supposed to do. But I can tell you don't like that because that's a lot of work, isn't it? So what did I teach you? Come back with me in a nice, pretty sky blue. What did I teach you? Well, I taught you a couple things. Okay. One, I taught you about the constant. What's my constant? 3, right? And it's the y-intercept. Hey, look, there it is. Check that out. Right? And I could have mirrored that one across and got that one, couldn't I? Or I taught you to use this leading coefficient, and we could go up 2 and over 1. I want to go green here. I could have went up 2 and over 1 from the vertex, right? Watch this. Up 2 over 1. Up 2 over 1. It's the same points. It's different ways of doing the same thing. Are you cool? I just want to show you what you're supposed to do so you can appreciate how much work I'm saving you. Got it? Let's do one more, and then I'm going to let you go. Okay? Let's do one more. Number 3 here. There is junk. So what do I have to use? Come on, speak up. There's junk. There's a linear term. What do I got to use? Thank you. X equals negative b over 2a. So in this case, it'll be the opposite of b. Well, b is a negative 12. So opposite of that would be a positive 12 over 2a. What is a? It's 3. So 2 times 3. Well, that's 12 over 6 or 2. Okay. So now I have the x value of my vertex. I know my axis of symmetry is going to be going through x equals 2. Somewhere there. Cool? All right. Now what? Glade. Plug it in. Let's find f of 2. Well, that's 3 times 2 squared minus 12 times 2 plus 7. 2 squared is 4. 3 times 4 is 12. 12 times 2 is 24. 12 minus 24 is a negative 12. Negative 12 plus 7 is a negative 5. So my vertex is at 2, negative 5. 1, 2, 3, 4, 5. There's my vertex. I'm going to go ahead and just use the simple stuff. I hope that's okay. So what should I use now that I have my vertex? My a value, my leading coefficient. What is my leading coefficient? It is 3. It's right here, 3. So from the vertex, I'm going to go up 3, 1, 2, 3, and over 1. Up 3 and over 1. Now, just to hammer this one home, I want to go ahead and use my constant too. What's my constant? positive 7. 1, 2, 3, 4, 5, 6, 7. It's right there. Remember, our constant is our y-intercept. And I'm going to mirror that thing across. So it should be right there. Okay. And here is my parabola. Cool? Think you can do that? All right, well, we're going to find out. Yes?
Should we just, instead of using the coefficient, can we just use the constant and say, like, pick one or the other? Or do you want us to do both?
I want you to do both whenever you can. The reality is the more points you have, the more accurate you are, and more chances of you finding a mistake if you made one. So use as much as you possibly can, okay? Your homework is going to be these sheets up here, and it's going to be the odds on those, and I'll be giving those out in just a second, all right? Have a great day.